We are Teikoku USA, the largest manufacturer of sealless, canned motor pumps in the world. Since 1956, we have designed and produced pumps for handling the difficult fluids commonly used in the petrochemical and refining industry. Thus, virtually all toxic, explosive, hazardous, and carcinogenic fluids are simply not a problem. Teikoku is also committed to safety, and we work hard to ensure that all of our products are environmentally friendly. In addition, effective March 1, 2003, ChemPump is now a division of Teikoku USA. This training video is designed to inform Teikoku representatives about the company's products and comparative benefits, and likewise to train in the diagnosing and evaluating of the existing pumping problems of potential customers.
I'd like to welcome everybody to Teikoku USA. This is going to be a presentation and basically a training video for use by our sales organization, reps. And I want to cover, essentially the highlights of our product, our organization, and how to sell our products and how we handle the competition. Teikoku USA is headquartered in Houston, Texas. The organization consists of Soji Sanahara, who's our president. I'm Denny Fagan, Director of Sales and Marketing. John Lumpkin is our regional manager handling primarily the refrigeration market. We have Brian Powers, who's an application engineer, along with Scott Yocklin, an application engineer, and Steve Tanner, who also, besides an application engineer, heads up our parts and repair organization. We also have Bud Clay, who works out of his home in Pensacola, and Bud is a regional manager. And that's pretty much the organization. We're backed, of course, by our organization in Japan, and all the products currently are manufactured in Japan. I want to talk about, number one, who is Teikoku? Teikoku is the largest manufacturer in the world of canned motor pumps. We currently produce over 2,000 units a month in our factory in Japan, and another 500 units a month out of our factory in China. All the units in China are manufactured purely for domestic consumption in China. There is no export of those products out of China. Right now, Teikoku produces more units in 1 month than the whole United States market for both canned motor pumps and mag drives buys in a year. I want to stress, though, that that is really in the ANSI sizes. This does not include fractional horsepower and mag drives such as Little Giant and that type of thing. But I'm talking ANSI size is 1.5 inch by 1 and greater. But at the same time, it also accounts for why Teikoku has been so successful, is simply because we built so many units, literally hundreds of thousands of units, compared to other people who only produce several hundred units a year. So our learning curve has been much steeper, and it really has shown up in the reliability of our products. What is a canned motor pump? And I say this because I know there's some people that really don't have a good understanding what a canned motor pump is. A canned motor pump is simply a motor and a pump combined into one unit, which eliminates all the packing and all the seals. Now, at the same time, what makes it work is that we separate the liquid from the motor with a thin alloy can, usually a Hastelloy, but also many other alloys can be used, and we encapsulate the motor rotor also in an alloy can, and hence the word canned motor pump. The thing that's really significant about a canned motor pump is that the motor housing becomes true secondary containment. Secondary containment is a very common word used in the nuclear power industry. If you've all seen the big concrete domes around a nuclear power plant, that's called a containment building. And so a canned motor pump has the advantage of, in fact, the motor housing becoming the secondary containment. So if there is a failure of the primary cans, the motor housing becomes. It's very important, however, that where the electrical wires come through, that they're also sealed, because what can happen is that if you get liquid into the motor and it's hot enough, it can turn to gas, and so the connections have to be actually gas tight. So it's really important that the unit is, in fact, even in a failure mode, eliminates any leakage to the atmosphere. The question really was, why would you buy a Teikoku over competitors? And in actuality, there's a really good paper that was written that compared our competitors, and I really have you take a look at this because it really discusses in detail the big differences between our competitors. However, if I really talk about what distinguishes us from our competitors is really reliability. As I was saying, what really makes Teikoku more reliable, there's really two things that I stress more than anything else. Number one, and the most important, is the fact is flow through the bearings. The bearings on a Teikoku pump have extremely large grooves, and these grooves are very, very important to the overall reliability. And why it's so important is if you don't cool the bearings sufficiently, then the actual product can in fact flash in the bearings, and when that occurs, the bearing really runs dry and the pump will fail very quickly. This is the number one cause of sealless pumps failure. After 20-some years of experience, and identified the fact that this is the number one cause, and yet none of our competitors do this today. So it's very important, and simply the fact is that we're putting 3 to 5 times more flow through the bearings than any of our competitors, and this really results in the fact of almost eliminating the possibility of dry running and flashing in the bearings. Very, very important. The other one is that balancing. When you have a unit, and keeping in mind that sealless pumps, cam motor pumps and mag drives, is that the bearings have to operate in the pump fluid. So the bearings are operating in an extremely hostile environment. They're not running in lube oil, not running in grease. So the fact is that these bearings have to survive in a very hostile environment. So it's very important that the rotating components, primarily the motor rotor shaft and the impeller, are balanced to a very, very high level of accuracy. And what Teikoku does as standard is that we balance all the individual components to an ISO 1.0. This is an ISO standard actually published in 1940, and it's a level of accuracy and balancing, 1.0 being the best, 6.0 and greater are the worst. So all the components in a Teikoku pump are balanced to 1.0. The assemblies, however, when you put it all together, we balance to ISO 2.5. Not quite as good, but at the same time, very, very, very good, and it results in very, very high reliability because you're putting much lower loads on the bearings. So it's really important that between the high flow through the bearings and balancing, how you get the life out of it. At the same time, the motors are designed to operate for a 200,000 hour design life. This is really important because if you run a motor at too high a temperature, the motor will fail. The average motor design life, by the way, for a motor is 30,000 hours. In a cam motor pump, since the motors are so difficult to replace and expensive, you want the motor to outlast the pump. So we actually have a design life of 200,000 hours. In reality, the motor should outlast the pump. And that's what we really want to do. The question is, how do we get a design life of 200,000 hours? Simply, you reduce the winding temperature. So if you have a motor, in the Teikoku case, our motors are designed as standard for 220,000 hours design life. So in fact, what you're doing is you're making sure the motor runs substantially cooler than its maximum design. So you in fact make sure the motor runs much longer. So that's how you get by reducing the motor temperature. Simple. Motors fail because they run at excessive temperatures. In fact, the electrical engineers tell us that for every 10 degrees C that you exceed the motor winding temperature, you cut the motor life in half. So you have a 220 degrees C system and you run it at 230 degrees C, the motor life will go from 30,000 hours to 15,000 hours. So it's very important to make the motors run cool. At the same time, the thing that has changed the cam motor pump reliability more than anything else has been reliable bearing wear monitoring. I cannot stress how important bearing wear monitors have become. To put it in perspective, back when I started 20-some years ago, nobody had bearing wear monitors. And we let motors run, pumps run until they failed. And so as a result, 90% plus of cam motor pump failures were catastrophic. Today, it's just the opposite. With accurate bearing wear monitoring, we in fact have reduced that now to a very, very small percentage, and it's usually because people ignore the monitors. And the monitors, I say, are standard on all Teikoku pumps. Whether you want it or not, you're going to get a monitor, and we do it in two ways. We have a monitor that's actually mounted right on the motor itself. That is a standard unit. And as I say, it's here. It shows it's standard on all the units. It's also available as a remote unit, so we can mount this on a control panel in a control room up to a couple hundred feet away. At the same time, it is progressive. It's not an on-off. I had some people call it a turkey popper. Some of our competitors is basically a gauge. It just goes from good to bad. And you don't want to do that. You want to have a progressive monitor that shows you how the bearing wear is progressing. So in fact, if you're only going to shut the plant down every couple of years, for maintenance, you want to know that the bearings are beginning to wear, and you want to change them at the time of the turnaround instead of waiting for a month after the turnaround and shut down. So progressive bearing wear monitoring is very, very important. And I say it's standard in all units. It also can, in fact, be put into a DCS system with a 4 to 20, shut the pump down automatically. A couple different ways, but it's important that the bearing wear monitors, has saved, I say, or caused the reliability to be greatly enhanced in cam motor pumps since the introduction. By the way, Teikoku introduced their monitor in 1980, so it's been around now for over 20 years. Another way that we get reliability, and it's really tied in with the balancing, is that the shaft sleeves are in fact machined to a very, very high tolerance, and in fact they're undercut at both ends, so just a very small part of the sleeve touches the shaft. And they're also notched to make sure that they always go back in the same plane after the unit is balanced. So as a result, not only do you have a very high degree of accuracy in the balancing, it's also repeatable, which is very important, so that you can take a unit apart after it's balanced and make sure the balance has been repeated when you put it back together. The same thing applies when you replace components. So you have to replace an impeller or sleeves. At the same time, the thrust washers, which mount again on the sleeve next to the shaft sleeve, are hard-faced as well as the sleeves, usually with stellite, to improve the reliability and at the same time get longer life. And the fact is that all Teikoku cam motor pumps are performance tested, every single one, which means that we have a baseline data. So when that unit is put in the field, we have a record of that motor and that pump, how it performed, so we can accurately predict what's going to happen in the field. And if there is a question in the field of how the unit's operating, we in fact have a record. No other manufacturer does this as standard. We test the flow, head at least 5 points, as well as the MPSH. So this is a really important feature that we offer as standard that nobody else will do. The question is, how do you get test reports? It's actually supplied with every pump automatically. In other words, when you get your documentation from Teikoku, we send out that test report as standard. There's no big question. We want people to have it. Teikoku is an ISO 9000 company. The ISO 9001, which is obviously very important in today's marketplace. At the same time, you may not be familiar, but there is in fact a pump standard issued by the API, the American Petroleum Institute. The old standby was API 610, which covered conventional pumps. 2 years ago, in August of 2000, October of 2000, there was an issue, or a standard issued API 685, which covers sealless pumps, mag drives, and cam motor pumps. There's very little difference in the two standards as it applies to pumps. Primarily the nozzle loads, units must be designed to ASME Section 8. And we have always complied with that. 685 though has much more specific requirements when it comes to testing secondary containment. And again, secondary containment is standard on a cam motor pump because the motor housing, it's much harder to achieve in a mag drive. And at the same time, I said the ASME Section 8, there is no code per se in ASME for pumps, but the industry typically uses the stress levels published in ASME Section 8 for allowable stresses, and that's exactly what Teikoku does when it designs its units. The question is, what's the cost structure of a cam motor pump versus a conventional pump, and what the return on investment might be. Life cycle costs have become very important in today's market because plants are running with fewer and fewer people, and in fact are looking for ways to maximize their investment and minimize their cost. Cam motor pumps typically cost anywhere between 50% to 200% more than a conventional pump. But what we're finding is that on our true life cycle cost, and in fact there's several papers that have been published concerning life cycle cost, and it really boils down to you've got to get the customer to look at not just the initial cost. We just had a letter from a customer the other day that they replaced a number of their pumps, mechanical seal pumps. They're currently saving over $200,000 a year in mechanical seal cost savings alone, just on the 30-some pumps they've changed. So there is a significant return on investment, but each customer has to look at their own. But really what's important, what we found, is that the most significant saving is on the install cost. That you can save 40% of the installed cost over a conventional pump with a cam motor pump because you have no millwright labor. You have no millwright labor, you have no alignments, no leveling of the base plates, and in fact you don't have to grout a cam motor pump base plate. So but we know that 40% of the installed cost you can save by using a cam motor pump. And if we can get that into the evaluation, that usually makes up any difference between a standard pump and the difference in a cam motor pump cost. The fact is we're going to run longer, I say 7.5 years is the average time between bearing changes, but most people won't give you that in the evaluation because that's down the road. They're going to get that further up, but we can get the 40% up front. So it's important that we get involved with the project early enough that the engineering company can give us that in the evaluation so that we can really see that kind of a savings. Okay, the difference between Teikoku and other cam motor pumps, as I said, we talked about the bearings, we talked about the balance, how important it is, and in reality, it's our broad coverage of product lines. The fact is that we offer a broader line than any other manufacturer in the world, and in fact, when you look at our latest brochure, you're going to see on the cover that we talk about a vertical inline unit. This has some real advantages we're going to talk about a little while longer. At the same time, we offer really a very broad range of products, starting with a unit like you see here, which is our standard horizontal unit. We call this a V-type simply because the product flow comes off the discharge across the rotor, back down through a hollow shaft, back to suction. It's a very, very typical unit and will really handle a large majority of applications. In turn, we go through a reverse circulation unit, which is really used for volatile units, fluids with seat vapor pressure curve, commonly used for refrigerants. And again, once we go to a vertical unit, and we use vertical units primarily because, again, a smaller footprint, they're easier to install, but at the same time, when we handle low viscosity fluids, steep vapor pressure curve, we reduce the loads on the bearings. And by reducing the load on the bearings, we increase the life. So vertical units will always run longer than a horizontal unit will, simply because we're taking load off the bearings. I can't tell you how much longer that is, but the fact is that a vertical unit will always run longer on the same application than a horizontal will. At the same time, horizontals make up a huge percentage of the market. And then we go into the jacketed units. We offer both a fully jacketed unit, partially jacketed. We can put steam jackets, water jackets on all of these pumps. And by the way, we can offer any of these pumps in vertical configuration, not a vertical inline, but we can actually take any pump just like this, put it on a fabricated stand, and offer it as a vertical unit. So all the pumps can be done. And then we go into the high temperature units, and here we'll talk a little bit more about those. That the high temperature units are offered essentially in two different designs. The more common one, and has been around for many times, it has no limitation really on size, is a water-cooled unit. Water-cooled units, I say, have no limitation on size. We build them up over 230 horsepower currently, and can handle a wide variety of applications. However, they have the big disadvantage that, of course, they require water cooling. At the same time, if you have water quality problems, or if you have limitations on water at the site, then we really want to go to what we call ceramic motors. The ceramic motors, of course, do not require any water cooling, and hence are more reliable. Unfortunately, they're currently only available up to 50 horsepower, so we do have some sizes. At the same time, the ceramic motors are certainly preferred when we have the right size, simply because they are going to be more reliable. At the same time, the same design philosophy applies to the ceramic motors, is that we make sure the motors run cooler than the maximum allowable temperature for the 200,000 hour design life. These, in fact, have proven, they've been built over 20 years now, have been proven to be incredibly reliable, and I can count literally on one hand the number of failures that we've had, and all of those have because of excessive temperatures caused by excessive starts when the motors are locked rotor. They handle a lot of high melting point materials, and operators will come in on Monday morning. The unit's been shut down over the weekend. The unit is solid. They continually push the button to try to start it, and the motors fail from overheating. That is by far the way these are failed. If they're run within the normal product ranges and the way they're supposed to be, they should outlast the pump without question. Yeah, the question was, are they available in the ANSI B71 size? And they certainly are. We currently have 11 sizes that are available as ANSI sizes. It does limit us somewhat in what we could offer in ANSI sizes, simply because we offer more models than non-ANSI sizes, but we certainly have ANSI sizes, and more are coming. So we certainly can offer ANSI sizes. We talked about the vertical construction. I said I want to go a little bit more into reverse circulation. Reverse circulation is really our way of handling volatile materials such as refrigerants. And what we do is we literally, instead of returning this flow back to suction through the hollow shaft, we actually add a flange here at the back end and take it away externally, which means we're not bringing the heated liquid back into the pump suction, but taking it away externally. And this has been proven extremely reliable. We have literally thousands of units on ammonia that have worked extremely well because of this feature. We also can supply slurry designs. I say the slurry designs are, in fact, where you bring in an external flush. And this external flush, it has to be compatible with the pump fluid, but the external flush allows us to segregate the bearings and put clean fluid in the bearings. And there's several designs that we can do, both either mechanical seals or close clearance bushings. And this really depends upon how much of the barrier fluid that you can put into your process. But the fact is, we can handle slurries extremely well. At the same time, we offer another slurry design. It's gas sealed. Gas sealed basically means we isolate the pump fluid with a gas barrier, as opposed to a barrier fluid with a seal. There's also a seal in the gas barrier, but at the same time, we separate the fluid from the motor with a gas barrier. And this is a very effective way of handling higher concentrations of slurries than you can with a standard slurry design. We also, in fact, offer a cell priming pump and multi-stage pumps, keeping in mind, again, that the multi-stage pumps can also be handled as verticals. The cell priming pumps cannot be furnished as a vertical configuration, but all the rest of the designs can be. Again, the bearing wear monitor is really important. I cannot stress often enough how important bearing wear monitoring is, and I stress reliable bearing wear monitors. There are competitors out there that offer bearing wear monitors, and they have not been reliable. It's a real concern, to mine anyway, that they in fact are trying to offer something that is not giving the customer the kind of protection they really deserve and need to make these products reliable. I get asked this question all the time. What's the difference between a mag drive and a cam motor pump? Again, the basic design is that they use product lubricated bearings. So the fact is, we have the same vulnerability to solids, to dry running, that everybody else has. There's no difference as far as that design is concerned. And I can make either one work well. The bottom line is, however, magnetic drives do not have secondary containment most of the time. There are a couple designs out there that do offer it. They offer a second can, very expensive to repair, but as a standard, they do not have secondary containment, which means if the unit fails, it can fail the atmosphere. And believe me, I know one customer where they recognized the difference, and they said, well, but we think magnetic drives can handle solids better than cam motor pumps, so they used magnetic drives and they put a containment building around the process. So they literally put a concrete building around the mag drives. That's not true. Mag drives are just as susceptible to solids as cam motor pumps. There's really no difference. It's the bearings that they're concerned. If you put silicon carbide or silicon, some kind of hard metal into that pump, it's going to wear bearings. You can't change it. Sizes. Teikoku publishes that we go up to 800 horsepower. In all honesty, we're really limited commercially, I feel, to 230 horsepower. Also, when you get to the multi-stage pumps, you have lower flows and lower heads simply because you're going to run out of horsepower. And when we talk about hydraulic coverage, there's no one can offer the hydraulic coverage that we do. We go from literally to well over 2,500 gallons a minute to heads of close to 2,000 feet. But again, concentrations, our sizes will vary depending upon the applications. We don't offer cell priming pumps as an example up to those sizes either. So again, we can get you quotations usually within one day. Get us the inquiries and we'll get the information to you. And the comparison between mag drives and cam motor pumps, I wrote this paper several years ago. It came out in Chemical Processing magazine, and I say it really goes into a lot of detail, and I really encourage you to use it. But the bottom line is, the conclusion is that the major difference between a cam motor pump and a mag drive is the fact that a mag drive lacks secondary containment. For all intents and purposes, that's the major difference. So customers have to realize that a mag drive can and will fail the atmosphere. And the question is there any advantage to using a mag drive? The best advantage is the fact that you can use a standard motor. So in a standard mag drive with a coupling, the fact is you can use a standard motor, and that is a big advantage. However, the reliability studies have shown that once you introduce a coupling between a motor and a pump, the reliability goes down 40 to 50%. So the couplings do allow you to use a standard motor. So what most magnetic drive manufacturers do is they offer a flange-mounted motor instead of a coupled unit to get better reliability. At the same time, that takes away the advantage of having a standard motor. When you go to a flange-mounted motor, the motor shaft now becomes the pump shaft, and you lose that interchangeability. C-flange motors are relatively easy available, but it's not a standard motor. You can't take a standard motor off and put another one with a flange-mounted motor. So you lose that advantage, but they do get the reliability. Okay, applications. Applications, I always tell people you can use cam motor pumps from everything from alcohol to xylene. But at the same time, where are they used the most? Historically, cam motor pumps were used on lethal services. So back 50 years ago when it started, typically they were used for phosgene, cyanide, HF. So you had lethal services. And that still is a portion of our business. However, what's happened is that people have tried to use them more and more, specifically for like hydrocarbons, and I call it difficult to seal fluids. So you start out with, you have the toxic, lethal services, which have historically been the units what have been used for. However, now you get into what I call the hard to seal fluids. Hard to seal fluids, or anything low viscosity. So typically they include light hydrocarbons, things like ethylene, propylene, any of the light hydrocarbons. At the same time, heat transfer fluids. Heat transfer fluids have a couple of things going. Number one is they are low viscosity and very difficult to seal. At the same time, they have some toxicity, and when they're operating up at high temperatures, you have certainly a safety issue. So if a mechanical seal fails, you in fact can spray hot oil around and really cause some problems for folks. We have one customer, in fact, General Electric up in Selkirk, New York. They had a mag drive fail, and that mag drive sprayed hot oil around, and the plant manager said, "Get them out of here." So we replaced over 13 pumps in that plant because of the problem of the hazard to personnel from the hot oil. Then you have typically just odorants, so sulfur-bearing compounds, mercaptans, H2S, sour water refineries. These are applications that we're seeing more and more of simply because the stuff smells bad. Heat transfer oils can also smell bad. Dow-Therm specifically smells bad. And then you have just expensive fluids. There's no toxicity, there's no real problem with them, except that they cost a lot. So as a result, any kind of a seal leak costs you a lot of money. So, and that is becoming an emerging market that people realize that they can have a significant loss of product and high cost loss, and they can avoid that by using the CAM motor pump. CAM motor pumps, by their inherent nature, are explosion proof. Been a lot of talk about labels, explosion proof labels, and what the industry needs today is they want third-party certification. What Teikoku has always done is we've had explosion proof motors for 35 years, and it's been in fact certified to JIS, which is a Japanese industrial standard, very similar to UL and FM. And the fact is all of our motors, or most of our motors I should say, are in fact can be supplied as explosion proof, and they're inherently explosion proof anyway, even without a label. So they're very safe, but we can in fact supply explosion proof models in most applications. However, you've got to be careful sometimes because the temperature and other classifications might make it that we could not furnish you a motor specifically for that application. So they have to be. Interesting though, as an example, the high temperature units, most of the codes don't allow that you can go to 400 C, 750 Fahrenheit is standard. Our motors have an explosion proof label at that level. So you can in fact use a T1 rating, it's called, at very, very high temperatures in an explosion proof area. Where I find the problem is that most plants don't recognize the fact they can operate, let's say, a heat transfer system at 750 degrees Fahrenheit, and they put a T3C rating on a motor, which is 180 degrees C, 347 Fahrenheit, but they actually, so they're actually in violation of the code because they're operating surface temperatures far above the motor rating. And it becomes an issue, especially with mag drives. So you have to be cautious to make sure if someone invokes a lower temperature rating on a heat transfer pump that you discuss it with them and you make sure it gets changed, which we cannot comply with that because our skin temperature on the motor will in fact be much higher. But in fact, explosion proof motors are certainly available. And the hot oil market, heat transfer, is one of our largest markets, and it's growing. Number one, it's very hard to get mechanical seals to work when you get to these high temperatures. Also, the hazard to personnel has always been a factor, but reliability is the key. As you get higher and higher in temperatures, the pumps see a lot of nozzle loads. They see a lot of pipe strain. And because of that, the pumps get out of misalignment. So a conventional pump, a lot of times when you get up to these operating temperatures, have misalignment issues. You see bearing failures, you see seal failures, and because a CAM motor pump has no couplings, we can take very, very high nozzle loads and eliminate that problem. So we get the reliability quite often simply because that these pumps can take very, very high nozzle loads, have no misalignment issues, and the reliability goes up accordingly. I call it weekends off. So we really want to stress the high reliability and all of our experience that we've had over the years in being able to prove this high reliability. And again, we talked a little bit about horizontal versus vertical. I can't stress it again. Vertical pumps will always be more reliable than a horizontal in the same application. And for all intents and purposes, there's no change in cost. So we try to really push the vertical units wherever we can, simply because it's going to be more reliable. It's absolutely essential to use them on very low viscosity fluids. I know a number of jobs where we've seen viscosities lower than 0.1, 0.01 type of things. They're absolutely essential. In fact, we'll turn down the order. If somebody comes up with a low viscosity application and they insist on using a horizontal, we'll turn it down. It's really important on low viscosity fluids. And as the units get bigger, it becomes more and more important. Question is about low temperature applications. CAM motor pumps love cold. Electric motors, as I say, don't like heat. So when you get into a cryogenic application, in fact, we have one running right now on liquid nitrogen at minus 310. But below about a minus 150 Fahrenheit, we have to start looking at some special designs. But down to minus 150, standard unit will do it, except once we get down below minus 40, we have to change the external parts that are carbon steel to, in fact, stainless. The whole unit has to be stainless below minus 40. But cryogenics are really a good application, a good point. The question was, what other industries are used for CAM motor pumps? Again, the most common one is the chemical industry. However, many applications in the refining market, and at the same time, high pressure, almost anywhere across. We see some testing laboratories that are using these units on high temperatures and high pressures, and any point where you have a difficult sealing problem, and it could be almost any industry we have out there. It could be pulp and paper, it could be almost any market that has a sealing. What we look for typically, though, is initially going into a plant is where they're having seal problems. By far, the easiest sell is to a company that's spending many thousands of dollars a month on seals, and there's usually one or two applications that they call bad actors in those plants. And that's what we want to concentrate on initially, is solve those problems where they have a really good return on investment by solving that problem. At the same time, you've got to be careful, because quite often the seal's failing, say, because of solids. And we want to make sure that we don't compound that felony by putting in a product that's not going to work. So we need to know, and one of the things that we really want to talk about a little bit is this guidebook is a way of, kind of a basic primer on CAM motor pumps. But one thing that's involved or included in this guidebook is, in fact, an application guide. And this application guide is really important. You cannot tell us too much about the application. You may not be able to fill this sheet in completely, but I tell you what, if you do half of it, I'll really be happy. You cannot tell us too much. So we need to know, what kind of problems they've been having, but specifically, are there any solids? What's the makeup of that fluid? The physical properties obviously are very important, but we really need to know what kind of problems they've been having. Quite often with a mechanical seal pump, it could be misalignment, and that's easy to fix. However, it may be the fact is they run the pump dry occasionally because of the nature of the process. We need to know that. We can, in fact, protect the pumps from dry running. In fact, we really recommend that you use a device like a load control, a power monitor, that will, in fact, protect the pump from dry running. It's the cheapest insurance I know of. And I'd like to see it on every pump. So besides the bearing wear monitor, the dry run protection, some way to make sure the pump does not run dry repeatedly is really important. Also, MPSH suction conditions, all of these are important, and we need to know what they are. We can work around them, and one of the things that a CAM motor pump can do better than most any other pump is we can handle low MPSH applications very well. But at the same time, we need to know what those are. And one word of caution. Inducers, and we have a broad range of inducers. Most of our pumps we can put inducers on. However, an inducer is really an axial flow pump. An axial flow pump has a unique characteristic. And in fact, that the MPSH curve on an axial flow pump is in fact a big U, which means at one specific point on the curve, we can really reduce the MPSH. But the MPSH required at other points on the curve can be higher than without the inducer. So you really have to be careful when you apply inducers, but they're very effective when we talk about lowering MPSH. The question was, what about pressures? There is no pressure limitation on a cam motor pump. We have built them over 5,000 psi now. You could go to 15,000 psi. So there is no real limit on pressure, on operating pressure for a cam motor pump. One of the other things I really want to stress is the fact that we have an extensive service organization, both within our service capability, our parts capability here in Houston, and we stock, and keep in mind, we stock at least one rotor and one stator for every size we've sold in the U.S. No other manufacturer does that, and it's a very, very important investment. That inventory does not turn over very much, but the fact is that we have to be able to support our customers. So if in fact a customer does have a failure, maybe it's a lightning strike, or an operator did something really dumb, the bottom line is they don't care what caused it. You've got to be able to support that unit. And if for some chance we don't have it in stock, we have the capability of rewinding that motor and getting it back in service very quickly. So our local stock's very, very important. We have 2 repair centers. And the fact is, though, that most of the repairs can be done on the plant site. The normal wear parts, which are bearings, sleeves, thrust washers. Thrust washers, sleeves, and bearings. And plus the gaskets are stocked here in Houston. You can have anywhere in the country in 24 hours. And believe me, we really work hard at making sure we can support our products. And the other thing I wanted to stress was that we talk about how to sell cam motor pumps. The easiest sale, by the way, is to replace existing competitive units. They've already made the decision to go sealless cam motor pumps. And when they're having problems, typically because of bearing wear, we can go in and offer them a more reliable unit, and that's by far. However, that market is relatively small. So we need to expand that market, and our biggest competitor is really a double-sealed ANSI pump. That's the Goulds and the Durans out there, and the people are having a lot of seal problems. We can offer them a real solution to that problem. The question is, can you change the speed? Cam motor pumps love variable speed drives. And in fact, I'd like to see more of them because one of the biggest problems we have in the pump industry is in fact that people oversize pumps. Because if you make the pump too small, the pump won't pump. So people historically oversize pumps, which means the pumps are larger than they have to be. So variable speed drives eliminates that problem, but cam motor pumps, because they don't have any fans, because one of the big problems we have is with variable speed drive is cooling the motor. Since there's no fans on a cam motor pump, we in fact can use a variable speed drive. The only thing I'd caution you about is make sure that the unit's designed for a variable speed drive unit, which means you have to put in some type of line reactor between the motor and the pump. Even with a spike resistant winding, we want to make sure that that motor is protected by using a suitable line reactor between the drive and the motor. But the pumps themselves love variable speed drives. And I want to finalize this by going over just some of the key points. This is we put out a standard proposal form, and in that form we talk about what makes Teikoku important, or what makes sealless pumps important to the customer. Is number one, of course, there's no leakage. This is the pump has a secondary containment. Is it possible? Yeah, anything's possible. People can blow them up. But we try very hard not to. And I personally, in my 8 years now with Teikoku, have never seen our containment fail. So we have, because of the conservative design, that certainly under even extreme conditions, you should never experience a leak. Okay, there's no alignment. It's very compact. There's a very small footprint. It's inherently explosion proof, and they're field repairable. No external lubrication required. You don't need oil pots, you don't need seal pots, and of course no mechanical seals or complicated seal systems. Okay, local support. Cannot stress it. How really important it is to back up your products. The balancing, I say the components to ISO 1.0 and 2.5 for the assemblies. 7.5 years bearing life, average. Also got to stress though, that's an average. Some units will run less, some units will run more. We've seen units that have run 24/7 for 25 years. But the average is 7.5 years between bearing changes. continuous, reliable, and I can't stress enough, continuous, reliable bearing wear monitoring. It's really important. Complies with API 610 and 685, and all units are performance tested. The question is, what about sound levels? Cam motor pumps, by their very design, have very, very low sound levels. There isn't a conceivable application where we would ever exceed 80 or 85 dBA. And in fact, most cases are much lower. So sound levels are in fact very, very low for this product. The question was about oil-filled stators. Oil-filled stators have been around since the 1950s. They were done, oil filling was done primarily to get more horsepower out of the motors. I personally consider it to be too much of a hazard. The earlier oils were in fact PCB oriented. And then they started going into transform oils, more friendly oils with silicone. But again, it was only used to stretch the available horsepower of the motors, to keep the motors from running too hot. Teikoku, basically, we limit temperature rather and don't require oil. But the motors are going to run much cooler. And in fact, one of our competitors, the thermal devices in the motor called TCOs, thermal cutouts, ours are set at the maximum motor temperature. Our competitor sets them at almost 50 degrees higher than the maximum motor temperature. They constantly burn out motor because they had too many nuisance trips, even with oil. So oil does not guarantee you the motor's going to run cooler. It was just a way to try to get more horsepower for less money. The secret really is to make sure the motor runs cool enough that in fact get maximum life out of it. Oil has nothing to do with that. The question is, why is the Teikoku bearing wear monitor better than the competition? Is simply, in fact, number one, it's continuous. In other words, it looks at the bearing wear continually, and in fact, to say the bearing was in fact going to wear very quickly, you could sit here and watch this needle go up. And we've seen a couple people have done that because the pump was running dry or was under extreme duress, and they could really see the bearing wear occur as it goes. Our competitors don't have a continuous readout. Now, the newer ones, there's two types of monitors out there currently. There's what I call the turkey popper. It's a pressure gauge. It's either good or bad. It's on or off. It's basically, it just shows whether it's when the unit fails. The newer ones, which have very fancy readouts and cost a lot of money, typically around $2,000 adder, is in fact that they get continuous readouts, but they're not reliable. They fail very rapidly, and many complaints that they have not been reliable. So it's reliability and the fact that they're continuous. The question really was, if the bearing wear monitor, once you change it, what happens to put a new bearing? It will go back to the original reading. So there's no additional cost, whereas I say the pressure gauge type of devices, it's a very expensive repair. You have to spend between $700 and $900 to replace that gauge because it actually has a physical contact inside and it wears off some metal and you have to replace it. So our bearing wear monitor, once you replace the bearings, goes back into the green again. The question was, is the bearing wear linear? Bearing wear is never linear. What happens when a bearing wears, and the initial clearance in a bearing is typically like 0.003 of an inch. So as the bearing wears, once it goes double, so once you get to about 0.006 of an inch, the bearing, actually the shaft running in the bearing now has a little bit out of balance, and so the wear becomes more progressive, so it's never linear. So if you looked at a monitor and it ran for 5 years to go one point on the monitor, it's not going to take another 5 years to go to the next point. It's going to be progressively faster because you're introducing it out of balance. The question is, what kind of fluids can we use in the refinery? Typically, most of the services are light hydrocarbons. So you have a lot of the pentanes, hexanes, ethylene, propylenes. However, we also see a significant number of benzene-laden, just traces of benzene in sour water, H2S in sour water, and those are the primary. So you have the light hydrocarbons and you have the benzene and H2S laden stream sour water streams. They're the most common in the refineries. Thank you very much.